sometimes described as waveforms, and sometimes it's can be represented by functions. And then today we also look into time transformation. Okay, time transformation, when we have a signal, how we do time transformations, which consists of time reversal, time shift, and then time scaling. Okay, so first of all, let us look at the functions. Okay, this topic is at section 114, mathematical representations of signals. So last week, I explained to you that signals can be also described as functions, and usually this function is described or explained or represented by a mathematical equation. So elementary functions that we will look into are the unit impulse, unit step, unit ramp, and later sinusoidal, exponential, and sinc functions. So we also learned about pulses and windows last week. And these functions are used as the elementary building blocks for modeling a signal. Okay. Okay, so let us look at the first function, which is called impulse. Okay, so if you look here, impulse, okay, also known as direct delta functions. Okay, so this is the equation. This is what I mean by mathematical, this one. So if you look here, it says that delta t equal to any functions, infinity or any function, any values at t equal to 0. So if you look at the graph below, figure 1.19, this is at t equal to 0. So we have a value of delta here of impulse. Otherwise, when t is not equal to 0, the values are zeros. Okay, so this is called impulse. Okay, now we will look into the concept of time transformations. Okay, so the first one, a delay. A delay of tau produces delta t minus tau. Let's say we have a delay of tau equal to 2 seconds, for example. Okay, so what happened? The original signal is the one in the middle. So when we say a delay of tau produces the impulse t minus tau, so okay, so delay is actually this one. Color. This one. Sorry. Thank you for highlighting it. Siapa tadi?
Wee Hong.
Wrong, eh? Okay. Thank you. Thank you for highlighting it. Okay. Okay, so the same goes for other functions as well. So let us look at other functions. So the second one will be, oops. The second one will be step input. So this is at step input. Okay. A delay of tau produces u t minus tau. So it will be this one. The color color just now. What color did I use? Okay. A delay and advance. Here. Okay. And then any question? Okay. And then the third most common signals that we will look into is unit ramp. So unit ramp, initially this is the equation. It will be RT. RT will be T more or equal to 0. Otherwise, T less than 0, it will be 0. So this is the middle one, the actual signal. So the same concept with the previous two functions, tau delay. This delay. And then advance. So this is okay. So any questions so far? So, okay, impulse. So we learn about impulse, unit, and ramp. Okay. Okay. Now let us look about the time transformations. So the concept of time transformation, these are the things that we will look into. The concept of shift, the concept of reversal, the concept of scaling, and the concept of combination. All these three time transformation techniques, combinations. Okay, so let us look at the first one first, the shift. Okay, so let's say we have a signal, and this time it is a sawtooth pulse. Okay, sawtooth pulse. Advancing a sawtooth pulse tau second. So in this example, it will be the tau just now. Remember the tau we discussed earlier. So x. So if the initial one is xt, okay. So when we have advancing, so it will be x t plus tau. Remember this one sebelum tadi. Okay. Advancing here. So go back to the sawtooth just now. So this is the original signal. So when we said it has a shift advance, so it will be the equation will give us something like this one, and then the sensitive. Okay, so we have time shifting of a sawtooth pulse. So this is advanced. What about delay, class? So delay, it will be xt minus tau. So in this case, it will be t 1 second. So kita tengok di sini, kita tengok first start dia di mana. So this one is 0. So when we have a delay of 1 second, so everything will be shifted to 1 second. So daripada 0 pergi ke from 0 to 1, and then 1 will be to 2. Okay, so that is on time shift, delay, and advance. So it depends on the value of tau. So far, so good. So whatever the 0 here will go, because they're advanced, so whatever the value of k, so the 0 will go to the -2, and the 2 here will go to the 0. So this is the signal that we have when xt experience of time shifting of k equal to 2. So k or tau, whatever the value. So this is time shifting advance. Okay, so the explanation here is how you want to figure it out lah. Tetapi kalau kita faham, if we understand about shifting and advance, so we know that the signal will go earlier, advance, whatever the K or the tau value is. Okay, so usually the amplitude will be maintained. So in this case, the amplitude is 2, but the one that will be shifted is the x-axis. Okay, and then delay. So delay, we learned previously that it will go to right shifting or time delay. Okay, so let's say this is our original signal. So we still have a sawtooth pulse with xt. When we talk about right shifting or time delay, so whatever the tau value is, so the signal will move to the will experience a right shift with the value of tau. Okay. So examples, let's say we have an examples here, the combination of sawtooth triangle signals. So when we say that this signal is having a right shifting or time delay of K equal to, in this case, is 2. Okay, so this is our original signal. And this is when the signal is experiencing right shifting or time delay of 2. So just look at the signal here, xt, and then this one is xt minus 2. So everything will be shifted to the right of a value k. Macam ni, minus 2 will become 0, and 0 will become 2, and 2 will become 4. So shifted to the right. Okay, so that one is for shifting right and left, or right is a delay, left is advance. Okay, so some examples here. What is the effect of one unit shift to the left and right of a unit step functions? So kita dah buat tadi. Okay, left to the right. Unit step just now here. Okay, left and right. Ataupun if we look, we do it by calculation. So it will be something like this. So to the left. Okay, so to the left and to the right. Okay. Okay, so the same goes for the exponential. So remember exponential last week, we learned about exponential. Okay, so what happened is that the t will be 1 unit shift, either to the left or to the right. So this is if we look into the equation itself. Okay, figuratively, so this is the concept, delay and advance. Okay, so far okay, class? Okay, so the first one is shifting left and right. Now let us look into time reversal. Okay, kita we understand the three concept first: shifting, reversal, and scaling. Yeah. So now let us look at time reversal. The effect of time reversal on a delayed input step functions. Okay. This one is originally a sawtooth pulse. Okay, so this is a sawtooth pulse and represented by this equation. Okay, so when we said that it has a delay, time reversal, time reversal. So the t will, everything will change into minus t. So remember the concept of time reversal that I mentioned earlier last week. It's as if you're folding the y-axis lah. Okay, so y-axis. Okay, so this is what happened if we look into the equations. Okay, and the same goes effect of time reversal on a delayed input step functions if we have it with the exponential. Okay, the point here that I'm trying to say is that whatever the t, if we try to do it mathematically or by equations, so when we said that the signals is undergoing time reversal, so all the values of t will change into minus t. Okay, so kalau tengok yang merah-merah ni, the one that has been transformed into minus t. So everything else remains. Okay, so that is the concept. And if we try to figure it out figuratively, so it is as if the signals is having a folding of y-axis. Okay, so let us look one example here. Okay, so this is again, we have the same signals. So the signals is having a time reversal. So basically dia terbalik lah. So it will be folding at y-axis. Okay, so mirror image folding or reflection at y-axis. So if we try to understand why it will be like this, we can try to do it mathematically. So initially our xt is 0, 2 and 0. And then we change the t into minus t. Okay, so kita tukarkan. So when we rewrite that, so this is what happened. When x minus t more than 0, it will be 0. So the signal will be 2 between 0 to minus 2, and less than minus 2, it will be 0. This is if we do it mathematically or by equations. So by figure, it will be mirroring at y-axis. So any questions so far? Okay, another type of reversal, this is a time reversal. Another type of reversal is amplitude reversal. So kalau kita tengok di sini, if we look here, when we said that time reversal, the one that change is the t. So t tu daripada yt pada y minus t, or xt pada x minus t. So the time itself having a reversal. So what about amplitude reversal? So amplitude reversal, dia punya negative is before the value of the coefficient. For example here, yt equal to minus yt. Okay, so there is a difference here. Previously, yt equal to y minus t ataupun x minus t. So this one is yt minus the t maintained here, the same. So the change, the negative is actually changing at the amplitude side of the signals. So let's say we have a signal here, the same signals. So what happens if we put a negative here, the amplitude reversals? So trying to do that, meaning that the t maintain, so t semua tak ada perubahan. If we compare before, t semua akan jadi negative, and then we rewrite that this is the final one that we having with this figure. So kalau negative at the amplitude reversals, only the value will be changed into negative values. So this is what happened if you look at the figure. So we have a figure here, the same signals, 0, 2, and amplitude of 2. And then when we apply the minus or the reversal, the amplitude reversals, what happened is that the signals is being reflected at x-axis. Okay, so in conclusion, for the reversal, for the time reversals, so the signals either will be a time reversal, which is figuratively by folding the signal at y-axis. For amplitude reversal, the signal is being reflected or folding at the x-axis. Okay, so far so good class for time shift, time reversals. Okay, now let us look at the combination of both, combining shift and reversal. Okay, so sometimes there are questions. There are questions by students. So which one shall we do first? Either shift or reversal. So it's up to you. So katakan macam these signals. So we have a signal of a sawtooth here. This is the original signals. So now we have to do, we have to draw, or we have to sketch a signal for this signal for x minus t minus 1. Okay. So kalau kita lihat kat sini, minus t meaning that the signal is undergoing a reversal, and then minus 1 meaning that it's undergoing a shift transformation. So these signals for x minus t and minus 1 is a combination of shift and reversal. So how do we do that? Okay. Saya tak boleh buat play because dia lari tadi. I don't know what happened. Okay. So this is the how the sawtooth pulse going from reversal, shifting, and so forth. So let us look at this example 1.25. So we have an original signals of sawtooth pulse with this equation, sort of like a RAM lah. Tapi RAM ni sampai, oops, salah ni, 0 to 1 Saya ambil daripada buku ke? Okay, saya tulis. Okay, so kita dah faham tadi konsep reversal. So when we say that the signals is transformed by the time reversal, so reversals meaning that here the t will change into minus t. So kat sini kita tukar minus t, and this one also minus t, and this signal also change into minus t. So bila kita rewrite balik minus t, less than equal to 0 and less than equal to 1. So it will, bila kita rewrite, dia dalam ni kena plus t So it will be like this, minus 1 to 0. So this is how the signals transform by signals reversal. Okay, now let us look at the reversal of xt followed by 1 unit shift to the right. Okay, so sekarang this is kita punya signal tadi, and then now kita followed by untuk C ni 1 unit shift to the right. So kalau kita kata plus 1, okay, sekali this is our signals x minus t. When it goes to x plus 1, okay, the signal will be here. Then the reversal of xt followed by 1 unit shift to the left. So the signals will go to here. Boleh faham tak kelas? Ada soalan? For this topic, combination of time reversal and time shift. So far so good? Okay, tak apa.
So far okay.
So far okay. Okay. So kalau kita lihat in terms of how we do it, sometimes we don't know whether we should do the reversal first or the shift first. Okay, let us look here. Time reversal followed by time shift, and time shift followed by time reversal. So let us look step by step. So let's say we have a unit step function, which is ut. And then when we say time reversal, so the t will change into minus t. Time reversal followed by shift to the left. So minus t minus 1. So I know that some of you might get confused with the concept of the first one. Mari kita punya time function tadi. Or unit function to this one. Okay. So kalau kita tengok dekat sini kan, unit function plus t, so it will be to the left. Unit function minus t, it will be to the right. Okay, so kita go back balik tadi. This one. Okay. Time reversal by shift to the left. Time reversal by shift to the right. Okay, kalau kita tengok dekat sini, okay, dia mula-mula dia reversal. First it reverse, and then it has followed by unit shift to the right. Right, kalau kita tengok tadi, unit shift to the right, dia punya signal adalah minus. Okay. So sekarang unit shifter to the right dia plus. Kenapa? Sebab dia go to the reversal first. Okay. Okay. Kalau kita tengok shift this one, the A, maknanya you can do both. The result will be the same. So the second one is time shift followed by time reversal. So we have the original function of ut. Now we do the shift first. So shift to the right. Kalau kita buat tadi, shift to the right. Shift to the right. So ut minus tau. Shift to the right. Okay, so I go back. Shift to the right. Tau dia satu lah in this case. So unit shift to the right followed by the time reversal. Okay. So I cannot draw here. So dia dah shift to the right and then dia reversal. Kita kata reversal tu apa? Reversal tu dia mirror at the y-axis. And that unit shift to the left and then followed by time reversal. So this one, ut plus 1 will be to the left and then the reverse. Okay, so the reverse, so it will be ut plus 1. So I need you to try to reflect this concept into figuratively for these photo signals. Okay. So both for C and D, try to do shift, compare reversal and shift, or shift and reversal. So you should get the same results here as stated by this example 1.26. So in conclusions, so this is how the signals are going through the shift and the reversal. Okay, and this examples is telling you for the exponentials. So at the exponential, when we said unit shift, so dia akan ada tau di sini, either plus or minus. So kita tengok shift right or left lah. And then whenever the signal after that signal having the shift, and then we reverse. Okay. Okay, for this one, dan yang lain-lainnya lah. Can try to look to understand the concept. So I go through the three concept first, and then we try to further understand the concept of all this transformation, shift, reversal, and scaling by more examples later. Saya dah bagi link apa tu, Jamboard nanti. Okay, so now let us look for the time scaling dulu. Okay, and then baru saya open pada question. So this is, let's say we have a signal here, again, the same signal, the sawtooth. Okay, so the sawtooth here, xt t minus 1 for t from 1 to 2. And then when we have a time scaling, okay, cuba tengok time scaling. Jadi bila time scaling, meaning that the time kita scale with either dia more than 1 or less than 1. Kalau more than 1, maknanya kita multiply with the numbers lah. Okay, for example, like this one, kita T tu kita timeskan, kita scale dia menjadi 2T. So whatever the T here, we have to change into 2T. So X 2T equal to 2T minus 1. So kita tengok di sini, kita rewrite kan dia. X 2T, this time scaling, let's say alpha ataupun beta dia 2. So whatever the value of T, we have to change into 2T. So bila kita rewrite, because dalam value equations T equal or T less more than, we have to be value of T. Yeah? So bila kita rewrite, we discover that X to T equal to T minus 1 for T between 0.5 and 1. So what can you conclude here, class? For time scaling, okay, of 2T or AT, the signal will be apa dia panggil compress of the value macam ini ya, daripada of 1 over whatever the value, katakan saya mention kat sini alpha. Mana dia bila dia time scaling, bila the value is more than 1, it will be compressed. Okay, another example, when the value is in this case is less than 1. So this is example of the exponential. Kita ada exponential biasa sini, exponential decay. So what happen if we have a time scaling of exponential with a value of less than 1? So in this example, the value is 0.2. Okay, so the conclusion that we get is that the plot of YT is having a scaling of, they expand. When the value of more than 1, the signal will be expanding, as compared with the value of more than 1 for the T, for the time, it will be compressing. Okay, so actually for the exponential example here, okay, kalau kita tengok find, this is the exponential exponential equation. Xt equal to E minus T minus, kenapa minus? Because it is a decaying examples, decaying exponentials. Times with UT, meaning that the value here will be 1 lah. Kalau dia times with UT, maknanya dia unit input. So now the signal is having, kalau kita tengok ke sini, first dia minus meaning reversal, and then 0.2T maknanya dia scaling. Okay, so scaling the of value of less than 1, and then ada plus 1, meaning that it's going the signal will going through shifting. Okay, so originally xt is exponential minus tut, and then we want to plot or to sketch a signal of yt which will go through reversal, this one, minus 0.2t scaling, and then plus 1 shifting. Okay, so how do we do that? So ini signal dia. Okay, so dia akan melalui reversal and then the shift. Okay, so shift dia banyak mana, because the t is 0.2, so we have to rewrite the equations. 0t tu kita jadikan kepada t. So now, if you look at the multipliers of unit input, so u will be minus t plus 5. So first the signal will go through reversal, and then it will be shifting to the right of sebanyak 5. Okay, so the reverse, and then since there is a scaling here of 0.2, kalau kita 1 over 0.2 is actually 5, so meaning that the signal will be expanding 5 times. So this is how the signal looks like. Dia besar lah. Dia apa? The expand 5. And then the shifting also 5. Here. Okay, ada soalan? Semua okey ke ni?
Okey, Doktor.
Yang lain-lain?
Tak ada soalan lagi.
Tak ada soalan lagi.
Okay.
So three concept of time transformation, which is shifting left and right, and then a reversal, and then reversal not much on the amplitude lah, kebanyakannya time reversal, meaning that time reversal amplitude dia akan tetap sama lah. Okay, and then scaling. Okay, so let us go to this example. Okay, now saya pergi kepada, I go to the keyboard. Stop sharing. So now I would like to go to Jamboard. Jadi tolong semua pergi Jamboard. Saya stop sekejap.